Here's section 6.4, which is log graphs. So let's take a look here at how we're going to graph this first one. Okay, so to do this, let's make an XY chart. And I'm going to write the formula that we have. Y equals log base 3 of x. What's going to be easiest for us to do in order to make our chart is to change this to exponential form. So if we change to exponential form, do you remember how that works? When you lose the log word, the base, the way I say it is the base stays the base, the other two switch, right? Because it's an inverse function. When you change from logarithm to exponential, you're looking at the inverse function. Here's a nice physical way to see it. Basically, you start with that base, right? The base stays the base, and you swoop to the y and back over to the x, meaning 3 to the y equals x. That's the same thing. The base, see how the base stayed the base, and the other two, the x and the y, see how they switch positions, and the y is up here now? And the x is over there. It's a nice physical way to see it. Now, when it comes time to make the table, because the y is over here as the power of the 3, we're not going to put in numbers on the x side first. That would not be the easiest way to go. Plug in for y 0, 1, and 2. So put in 0, 1, 2 for the y. And what will the x equal? The x will equal 3 to the 0, the x will equal 3 to the 1, and the x will equal 3 to the 2, right? Plugging in for the y, 0, 1, or 2. So what's 3 to the 0? Anything to the 0 power is 1. Anything to 3 to the 1 is just 3. 3 squared is 9. So let's put a couple of those dots on the graph. So over 1 up 0. There's that one. And then over 3 up 1. There's that one. And then over 9 up 2 is right there. So the graph is going like this. And that's generally how log graphs look. They're concave down. They're like a bowl turned down. They're the inverse, the opposite of an exponential. Remember, exponential graphs look like this. That's what exponential graphs. So they're concave up. They're like a bowl turned upward. They're rocketing upward. Whereas a log graph is like a bowl turned downward, concave down, generally. There's always exceptions and special cases. All right, number 2. So they want us again to graph here this log function. So let's give it a try. So let's make a couple observations. Here's the first thing I want you to know. Whatever number, the number that makes the inside of a log parenthesis, right there. I'm not saying that very clearly. The number that makes the inside equal 0. So what number? That'd be 2, right? If you plug in 2, it'll make the number that makes the inside of a log parenthesis equal 0. The number that does that is the vertical asymptote. So that's going to be at 2. There's the vertical asymptote. That's important to find. And then when we start to make our XY table, we want to plug in numbers. 2's not going to work. So you could try it if you wanted to. But if you plug in 2, it won't work because it's y equals log base 3 of 2 minus 2 plus 4. That's going to be log base 3 of 0. And the log of 0 is an error. So that won't work. So then we go up from there. So that tells us where we start. We go up from there. So let's plug in 3. So y is log base 3 of 3 minus 2 plus 4. And what's that? That's log base 3 of 1 plus 4. Now, how do we do log base 3 of 1 on our calculator? We don't have a log base 3 button. Well, this is where I'm going to give you a special formula. It's called the change. Here, let me change the color while I write this. It's called the change of base formula. And it says that anytime you have the log base b of a, you can write that as log of a over log of b. You can make it into 2 logs. It's called change of base because, so this is 1 log and these are 2 logs over here. And both these logs have a base of 10, don't they? Because they're not showing their base. Remember, whenever the base is invisible, it's really a base of 10 with the normal log word. If you have ln, that one has an invisible base of e. But if you have the normal log word with an invisible base, the base is 10. So we just changed the base. Log base b became 2 log base 10s. 1 log base b just became 2 log base 10s. It's called the change of base formula. I'm not going to prove it, but you can prove it easily. It's a true statement, and we use it a lot to solve logs. And here's the deal, because we can do these on our calculator. Those are just regular logs. We can hit the buttons. Whereas this one, we have no log with a base of b, or in this case, base 3 or whatever. We don't have a button for that, but we change it. And notice the way it goes. The base one goes to the bottom, and the other one goes to the top. And that makes sense, right? Base is always on the bottom. So the base to the bottom. Okay, so let's do that over here. So the base to the bottom, the log 3 goes to the bottom, and the other one is on the top. So 1 log becomes 2, and you still have the plus 4 out there. Now, why we do that is because now you can hit the buttons on your calculator. Now you can type log 1 divided by log 3, and it'll be 0. 0 plus 4 is 4. So that's the point over 3, up 4. Now we've got a log point. Okay, let's get one more. Let's go one higher. Let's plug it forward. Now remember, we started at 2 because that's what made the inside 0, and we went up from there. Now we've got y equals log base 3 of 4 minus 2 plus 4. What does that give us? Log base 3 of 2 plus 4. Remember, so now we do the change thing here. We don't have a log base 3 button on our calculator. We just have a regular log button. So we make that into 2 logs. Remember, the base goes to the bottom always. The other one's on the top. So if you hit the buttons on your calculator, what you'll get for that first part, this first part right here, is some weird decimal. I'll do it right now as well. Log 2 divided by log 3. I'm getting 0.63. Then you add the 4. You're going to get 4.63. I'll just put 4.6. Now that's a valid point. Over 4, up 4.6. It's about right there. But it's not a point we can really use on our graph because we can't click the exact spot. It's a decimal. So we need another one. And we have to be kind of smart about this. How so? Well, what's going to give you a nice easy point is to pick a number that you plug in that makes the inside the same as the base. So what could I plug in for x to make the inside be 3 like the base? 5, right? If I plug in 5, see what I'm going to get here? Let me come over here. I'll do it up here. If I plug in 5, I'm going to get y equals log base 3 of 5 minus 2 plus 4 log base 3 of 3 plus 4. And remember the trick, when you get the log of a funny base, you make it into 2 logs. The base goes to the bottom, the other one stays on the top. And I don't need a calculator for that. Log 3 over log 3 is same thing over itself is 1. 1 plus 4 is 5. Do you see how that worked nicely so I get a whole number answer? So that's what we do. So over 5, up 5, right here. Over 5, up 5. So on the graph making tool, you just select the, right there, the horizontal, the vertical asymptote, and then the 2 points 3, 4, and 5, 5, and it makes this graph automatically for you, this log graph, and this goes down, you know, forever, getting closer and closer to that line forever without ever touching it. Now they want the domain, the range, and the asymptote. Let's come down for the asymptote. That is going to be easy to find. The asymptote on this one is going to be x equals 2. Right? The vertical asymptote hits the x-axis at 2. What's the range? Remember, the range is like the up and the down. The range is how low the graph goes and how high the graph goes, from bottom to top. So the graph goes from negative infinity to positive infinity. It goes down forever and up forever. Last question, what is the domain? Kind of doing these in backwards order. The domain is how far left the graph goes, and then comma how far right. It's left, comma, right. So how far left did this graph go? Well, it goes to 2, and it doesn't quite touch to the 2. Remember, this piece of the graph, this log piece, comes down closer and closer forever to that dotted line at 2, but it never touches it. You never touch a vertical asymptote. So I'm going to put a parenthesis by that 2, not a bracket. Remember, brackets mean you're straight on the number. You hit it, but we don't hit the 2. All the way to infinity. It goes from 2 to infinity, left edge, comma, right edge. There's the domain. So notice the domain is from 2 to infinity. There we go. Let's try this one, number 3. Similar kind of situation. XY chart. Now remember, we're going to, what do you plug in? What makes the inside of the log equals 0? That's where the is the vertical asymptote. So what, that'd just be 0, wouldn't it? Just 0 itself is what makes that happen. So right at 0, at x equals, that's the, and I'll put that down here already for the asymptote answer. X equals 0 is the vertical asymptote. It's what makes the inside, whatever makes the inside of a log 0, because you can try it in your calculator. Log of 0 is not going to work. Here, I'll write it here for us. 0, y equals log base 4 of 0 minus 3. If you do that in your calculator, give it a try. It'll give you error. Log of 0 is an error. So that's no, that's the vertical asymptote. Then we go up from there. Now let's plug in x is 1. We get log base 4 of 1 minus 3. Now remember how we do this? When we have a funny base, like log base 4, we make it into 2 logs. And the base goes to the bottom. The other one's on the top. hit the buttons on your calculator, you'll get 0 minus 3, negative 3. So that's the point over 1 down 3 right there. And now we can go like to 2, but if you do, you're going to get some ugly decimal number. I mean, it's okay, but you can't put it on the graph. How do you know? What do you got to get a nice whole number? If you do 3, you'll also get some decimal number. Remember, you've got to go until it matches the base. The inside has to match the base. So plug in 4. That'll work nicely. So what do we get? So we get the base goes to the bottom, always. The other one's on the top. This is easy. I don't need a calculator there. That's just 1. Same thing over itself is 1. 1 minus 3, negative 2. So over 4 down 2 right there is that point. Over 4 down 2. And that's all we need is 2 dots. We can graph the thing now. It's going to go like that. There's the log graph. It's concave down. It's like a bowl turned down. So notice again, we pick what makes the inside of the log 0, and that was just 0 in this case. And then we pick what makes the inside of the log match the base, and that was 4. The domain is left edge, left, right. The left is 0 to infinity, right? Parenthesis on that 0. It doesn't quite touch that 0. And the range is the up and the down. That's my range. And that goes from negative infinity to regular infinity is our range. Okay, so here we are on number 4. So we're going to graph the following function showing the 2 points. Okay. So how do we do this one? Again, we're going to notice that, oh, this one's actually exponential, huh? So let's just make an XY chart. And let's start. I can just plug in any number. So how about x equals 0 to make things easy? I'm going to plug in a 0. So this is not a log. Notice it's an exponential function. Plug in 0. So y will equal 3 to the 0 plus 1 minus 2. And that's 3 to the 1 minus 2, which is 3 minus 2 is 1. So over 0, up 1, right there. Now, let's plug in 1 for x. If we plug in 1, we'll get 3 to the 1 plus 1 minus 2. That's 3 squared minus 2. 9 minus 2. Whoop, getting a little scribbly there. 7. So over 1, up 1, 2, 3, 4, 5, 6, 7, about right up there. Now that's a valid point, but it's not on our graph, so I'm going to have to go the other way. How about back to negative 1 so I can get something on my graph? So if I plug in negative 1, I get y equals 3 to the negative 1 plus 1 minus 2. That's 3 to the 0 minus 2. What's 3 to the 0? What's anything to the 0 power? It's 1. 1 minus 2, negative 1. So that's back 1, down 1. That's right here. Back 1, down 1. So it looks like the graph goes rocketing up like this. Now remember, this is an exponential graph, right? The x is in power. So that means it's exponential. Yeah, they say it right there, exponential. So those always launch on one side and flatten out on the other. So it must, if it launches here on the right side, it must flatten out on the left side. And what is the height at which it flattens? Remember, this number right out here is always the horizontal asymptote. So negative 2, so this is negative 1, and right here at -2, that's where it flattens out. That's the horizontal asymptote. Okay, now the second part, this is still number 4. This is part B now. Now they want me to graph a log graph. The point of this example is we're comparing an exponential graph with a log. And notice they're inverses of each other, right? This is 3 to the x plus 1 minus 2. This is log base 3x minus 1 plus 2. See how it's opposite? They're inverse functions of each other. Graph's going to be the opposite. So how we graph it. So let's make an XY chart. Now remember, whatever you plug in here, what makes the x that makes the inside of a log 0 is the vertical asymptote. So what is that? It's going to be 1, isn't it? So plug in 1, you'll get y equals log base 3 of 1 minus 1 plus 4. That's log base 3 of 0. If you try that in your calculator, log of 0, it'll say no, and that's because that's where the vertical asymptote is. So you don't really need to plug it in. I was just doing that to demonstrate. But we'll just go ahead and at x equals 1, we'll just put the vertical asymptote. And then we'll go up from there. So let's plug in 2. Log base 3 of 2 minus 1 plus 2. Oh, where did I get that plus 4 out there? Sorry, that's plus. It doesn't matter. It was still a no. Okay, so then this is log base 3 of 1 plus 2. Now, how do we do log base 3 of 1? We don't have a log base 3 button on our calculator. So what we do is we make it into 2 logs. Remember, the base goes to the bottom. The base goes to the bottom. You make it into 2 normal logs. See, no base. There's no base there. There's no base in the other, which means normal log, base 10, really, invisible base 10. Then you just hit the buttons on your calculator. You'll get 0 for this first part. This first part will come out 0 plus 2 is 2. So we get the point over 2 up 2 right there. Now we need one more dot. So how are we going to get the other dot? Well, we could go to 3, but again, if you do that, it's not going to work well. I'll show you. You're just going to get a decimal. You'll get log base 3 of 3 minus 1 plus 2. You'll get log base 3 of 2. And then how do we do these weird log base 3s? We put the base on the bottom. Remember, you make it into 2 logs, put the base on the bottom. If you hit the buttons on your calculator there, and then add 2, you'll get 2.63, or I'll just say 2.6. So over 1, 2, 3 up. What is it? 2.6. But about right there. Again, that's not an easy point to put the dot on our graph. So instead, what should we have picked? You want to make the inside the same as 3. You want to make this whole. You want to pick some x to make the inside of the log equal the base. The base is 3. So what x will do that? X is 4 will do that, won't it? Right? Because if you put a 4 in there, 4 minus 1 is 3, it'll match the base. That's the x that'll work nicely, give you a whole number. So let's plug in 4. I'll come up here real quick. Maybe erase some of this. I'll plug in 4. So we'll get y equals log base 3 of 4 minus 1 plus 2. Log base 3 of 3 plus 2. And remember what we do with these logs? The base goes to the bottom. The other one's on the top. And what's log 3 over log 3? Well, the same thing over itself is always 1 plus 2. This is 3. So that's the point over 4. 1, 2, 3, 4 up. 1, 2, 3 right there. So over 4 up 3. Okay, how does this graph look? The graph is going to go like this. There's the log graph. See how it's the opposite of this other one? They're inverses. It's concave down. This is concave up. There we go. Now, on this one, this is question number 5. Let me write it up here. They want us to match the formula of the logarithmic function to its graph. Match the formula to the graph. So, how's that going to work? Well, this is a little tricky. Best way is to go graph each of these separately and then find the graph. So let's do that. Let's go to some fresh paper here where we got some room. So this is question number 5. So first off, we're going to graph y equals minus log base 4 of x. Make an xy chart. Now where should we start? Remember, the x that makes the inside of a log 0 is the vertical asymptote. So that would just be 0 straight. You could plug that on your calculator, you'll get no go. That is the vertical asymptote. So when I graph that one, graph it over here, that means right at x equals 0. I'm going to get a vertical asymptote. Now let's go up from there, plug in x equals 1, y equals negative log base 4 of 1. Now how do we figure that out in our calculator? Remember, we make it the base, so we keep the negative, and the base goes to the bottom, and you make it into 2 logs, and the other part you keep on the top. That's the change of base formula. The base goes to the bottom, you make it 2 logs. Hit the buttons on your calculator, you'll get 0 over 1 up 0. Now let's go to 2. We'll just go up one more. Right. Oh, remember what we could do 2, but what's going to be easiest is to pick a number 2, or the x, to make the inside the same as the base. That'll make it easy. So let's pick 4. That'll just be easier. Log base 4 of 4. Again, the base part goes to the bottom. The other log of 4 on the top, that's negative 1. Y is negative 1, so that means over 4, 1, 2, 3, 4, down 1, over 4, down 1. Okay, so what is this log doing? Now we know they always get close to the y-intercept, so we have an idea now. This log graph is going like this. It's upside down from a normal log. So there's that one. So we can go and we can figure out which one that is. So going back here, that would be this one is part A. Let's do B now. Minus log of 2/3 x. And so 5b, this was 5a. So y equals minus log of 2/3 x. Okay. XY table. Remember, whatever makes the inside, so 0 makes the inside of the log 0, x equals 0, is our vertical asymptote. So that is our vertical asymptote. You could plug it in, but it won't work. It's your vertical asymptote. So we've got that point already, vertical asymptote. Now, what do we want to do from here? Well, the other thing we want to plug in is you want to plug in x equals whatever number to make the inside of the log the same as the base, right? We always pick x to make the inside 0 and to make the inside the same as the base. So that would be 2/3. Right? If we make 2/3, then y will equal minus log base 2/3 of 2/3. So that'll be minus, and then the base goes to the bottom. The other one's on the top. And that's just -1, isn't it? Because the same thing over itself is 1. So -1. So that's over 2/3. So this is over 1. 2/3 is a little before that, about right there. Over 2/3 down 1. It's kind of funny. Okay, what do we need one more dot. What should we do? Well, let's just do x is 1 because that's an easy number. Y equals minus log, of 2/3, of 1. How do we work that out? Remember, the base goes to the bottom. So the base goes to the bottom. Hit the buttons on your calculator, you'll get 0. Because it turns out the log of 1 is always 0. 0 over anything is 0. So over 1 up 0. So we're getting that. So we're getting those two dots. Okay, so it looks like the graph is going like this. Now, it's kind of tricky to go find the right one because two of them are going to look similar. But remember, this is 2/3. This dot right here is 2/3 of the way over, not halfway over. So let's go back. So part B, it's this one. See this right here, how this is B? Because that's 2/3 of the way over. See this dot right here is past halfway. This one's similar right here, but this one's exactly halfway, isn't it? It's right in the middle. Right there, that's halfway. Ours is a little past middle, 2/3 of the way. So that's our graph right there. There's part B. Let's go graph C and D now, log base 2 of x. Log base 2 of x. So we're going to make an XY chart again. We're going to make x 0. That's going to be the no spot because whatever makes the inside x that makes the inside of the log 0 is always your vertical asymptote. So again, we have a vertical asymptote that is 0. And then what should we do from there? Go up by 1? We could do that. So y equals log base 2 of 1. Remember how we changed that? We would let the base go to the bottom. Hit the buttons on your calculator, you get 0 over 1 up 0. And then what would be easiest to plug in? Remember? X that makes the inside of the log the same as the base is an easy point. It'll be a whole, that'll be a whole number. It'll always be a whole number point. So what do I plug in there? 2, right? So that'll be, bring it down here, that'll be y equals log base 2 of 2. Again, the base goes down, the other one stays in the top. That's just a 1, same thing over itself as 1, over 2, up 1, right there. So it looks like our graph, our log graph goes like that, doesn't it? So go back and find that one. So which one looks like that? It's this one. See, over 2, up 1, and this is C right there. And so that last one, what we have left is D. It must be D. It's the only one left. We can see that real quick. So 5D. We're going to write that one. That's y equals log base 2/3 of x. So what do we start with? We start by plugging in 0. That's the vertical asymptote, right? Whatever makes the inside 0. So right there is the vertical asymptote. And then we plug in 1. Hit the buttons on your calculator. Remember, the base goes to the bottom. Whoops. The 2/3. So the base goes to the bottom. The other one's on the top. And that's just 0. Over 1 up 0. And then one more. What should we plug in? You want to make the x to make the inside equal the base. Equal the base. That'll be a whole number. That'll be a whole number spot. So plug in 2/3. So if x is 2/3, you get log base 2/3 of 2/3, which, remember, the base goes to the bottom. When you make it 2 logs, log 2/3 over log 2/3 is going to be 1. So over 2/3 up 1. So it's about right there. So this graph must be going up and then coming down like that. Sure enough, that's what matches 5D. There it is. It matches. Good, that was a long one. Okay, number 6. Which of these is right? The graph of y equals log base 2 of x. This should be easy for us now. We'll just make an xy chart. And whatever makes the inside 0, that's our vertical asymptote, isn't it? So we know right away the vertical asymptote is 0. So this is no, because his vertical asymptote looks like it's somewhere over here. And this one has a vertical asymptote over here. No way. It's one of the other two which has a vertical asymptote of 0. Now let's plug in 1. Y equals log base 2 of 1. Remember, the base goes to the bottom, the other one on the top. That'll be 0 over 1 up 0. So over 1 up 0, over 1 up 0. They both have that point. Now let's go to 2, because we want to make the inside match the base. So we get y equals log base 2 of 2, which is log 2 over log 2, which is 1 over 2 up 1 over 2 up 1 right there. It's that one. This one over 2 up 1, no, it's not hitting that point at 2, 1. So this is our answer. That's what it must look like. Number 7, same kind of thing. Let's graph it. So we're going to make an XY chart. Get some room here. Okay, make an XY chart. And what am I going to plug in first? Remember, you plug in X to make the inside equal 0. The inside of the log equals 0. So what's that going to be? Negative 3, isn't it? Plug in negative 3. And you could do it on your calculator, but you'll just get log base 3 of 0, which will be air, which really means that's where the vertical asymptote is, at negative 3. So the vertical asymptote's at negative 3. So this one's a no here, and this one's a no here, because they have vertical asymptotes over at positive 3. That's not right. It's this one, which has got a vertical at negative 3, or this one of those two, which has a vertical at negative 3. Where should we go from here? Now just go up by 1. So just add 1, just go up by 1, negative 2. So what we always do, right, we start with a vertical, which we can't actually touch, and then we go up by 1. So plug in negative 2. You get log base 3 of negative 2 plus 3. You get log base 3 of 1. Remember, we changed that with the base goes to the bottom. Right, base to the bottom. Other one on the top comes out 0. So back 2 up 0 right there. And right there, they both have that point. So we need one more point. What should we do? Now what you want to do, remember how we always do the other point? We want an x to make the inside equal the base, because that'll be a whole number. So what x can I plug in to make the inside 3? 0. If x is 0, that'll make the inside 3. So plug in x is 0, and you get log base 3 of 0 plus 3. Log base 3 of 3. The base goes to the bottom. The other one's on the top. And that's 1. So that's over 0 up 1. Beautiful. There it is right there. Over 0 up 1. No, that one misses it. So there's our answer. That one has the right 2 points and the right vertical asymptote. Okay, number 8. Same kind of thing. We got to graph it. And want to start with what x to make the inside equals 0. What's that going to be? Just straight 0. X equals 0 is the x to do that. So we start with that. Make our xy chart. X is 0. That's going to be our vertical asymptote. Because if you plug that in, you're going to get log base 3 of 0 plus 3. This part will give you an error in your calculator. That means that's the vertical asymptote is at 0. So the real graph has a vertical asymptote right here at 0. So this one's good, vertical asymptote at 0, and this one's good, vertical asymptote at 0. This one has got a vertical asymptote over at 3. That's a no-go. And this one also has a vertical asymptote at 3, no-go. So we're down to 2 answers. Let's then we go up by 1. Once we have our starting point, we go up by 1. Y will equal log base 3 of 1 plus 3. Y, now what do? Remember, we turn that into 2 logs. The base goes to the bottom. And that'll be 0 plus 3. That'll be 3. Over 1 up 3. Right there. Over 1 up 3. But this one has it too. Over 1 up 3. They've both got it. So which one's the right answer? Well, we got to do one more point. Now, what else should we plug in that's going to be easy? We could do 2, next, but that won't be easy. Remember, you want to plug in the x to make the inside equal the base. So I'm going to plug in 3. That'll be the easy one. Y equals log base 3 of 3 plus 3. And then when you have this double log thing, the base goes to the bottom. The other one on the top. So that's 1 plus 3. That's 4. Y is 4. So over 3 up 4. Yeah, right there. Perfect. How about the other one? Over 3 up 4. No. Misses it. So there's the right answer on that one. There we go. Number 9. So we're going to graph this one to find out which of these is the correct answer. So, XY chart again. And we're going to start with the X that makes the inside equal 0. That would just be 0, wouldn't it? So we start there, and that's going to be where the vertical asymptote, that is your vertical asymptote. You could plug into your calculator, but you'll just get an error. Log 1/6 of 0. It'll tell you error when you do that. So then we go up from there. Let's plug in 1. Y will equal log base 1/6 of 1. Remember, we make that into 2 logs. The base goes to the bottom. Always, the base is always the bottom. Hit the buttons on your calculator, you'll get 0. I'll just write it down here. You'll get 0 for that. So over 1 up 0. Let's start eliminating some possibilities. We got to have our vertical asymptote at 0. So this one, its vertical should be right there. Not working. The vertical should be right there. No. Vertical should be right there. So far, yes. The vertical should be right there. So far, yes. So it's one of those two. Now, let's, what do we do for our next point now? What would be another one that's good to do? Well, usually we plug in something to make the inside match the base. X to make, the inside equal the base. So we get rid of this right here. What can we pick to make the inside match the base? Well, 1/6, huh? We got to pick 1/6 to make the inside match the base. Then we get y equals log 1/6 of 1/6. So now the inside matches the base. So you make this into 2 logs, a fraction with 2 logs. The base goes to the bottom. The other one's on the top. That's 1. So over 1/6, over just a little bit, up 1. Over 1/6, up 1. Yeah, that sort of looks like over 1/6 up 1, doesn't it? How about this one? Over 1/6 up 1 would be right here. No. This one's now a no. So there's our graph. That's the right one. Number 10. Choose the graph of y equals log base 1/6 of x plus 5. Okay. So again, remember, we want the x to make the inside equal 0 is our vertical asymptote. So what's that? -5, right? Whatever makes the inside 0. So that's how we start our xy table. -5, and that's going to be the vertical asymptote, because if you do it on your calculator, it won't work. It'll just tell you y equals log 1/6 -5 plus 5. That'll be 0. It'll be error, and that's our vertical asymptote. So you got to have vertical asymptote -5. That'd be right back here. That one's therefore a no. Right back here. That one's a no. Back here. Yes, so far so good. Back here. Yeah, so it's one of those two. So we need some more points. So let's go, what should we do from here? Let's go up by 1, -4. So we get y equals, bring this down a little bit, y equals log base 1/6 of negative 4. See how I went up by 1. That's what we do. We start with that vertical asymptote, then we go 1 to the right of that. And so what do we get? Log base 1/6 of 1. Do this on your calculator. Remember, the base goes to the bottom when you turn it into 2 logs as a fraction. Hit the buttons, you'll get 0. So minus 4, 0. Yeah, that looks good. Same thing here. Minus 4, 0. They're both looking good so far. Now we need one more point. What should we pick? Well, what we do, remember how we always do this? We pick an x to make the inside, well, this is going to be tricky. Normally, I mean, we could do it, but it's going to be tricky. Let's just use our calculator. Probably the easiest thing. So we're down to these 2 yeses. The whole question is, way off there, like at 10, is it up here positive, or 10 would be like over here. 10, is it down negative? Right? We need to figure out which one. So let's just plug in 10 and see which of those is correct when you go way over to 10. So let's see it. So y equals log base 1/6 of 10 plus 5. What do we get? Y equals log 1/6 of 15. Remember how to do that in your calculator. The base goes to the bottom. The other one's on the top. I'm going to do it on my calculator right now too. So log 15 divided by log of 1/6. I'm getting negative 1.5. So way over at 10, it's down. That's the right graph. See, it's going down. Right at 9, 10, it's down. This one's positive. That's a no-go now. At 10, this one's up at something positive. So there we go. That works. Number 11, they want us to match each equation with a graph above. So how do we match the equations with the graphs above? Well, if you notice, 2 of them are logs and 2 of them are exponentials, where x is in the power zone. Anytime you have an exponential, well, it's these 2 are the exponentials, aren't they? Because they're rocketing up. And these 2 are the logs, log or natural log, I'll say, because they're not going up, they're concave down. So exponentials are always concave up. They're like a bowl turned up. And logs are concave down. They're like a bowl turned down. Okay, so now the trick is you got to know what E is. E is a special number. Like pi is a special number. Pi is 3.14, blah, 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 blah. Well, E is 2.718, blah, 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 blah. So just remember, pi is a special number, 3.14. E is a special number just under that, 2 point something, That's all you need to know. It's 2 point something. So what does that matter? Well, this is basically like 2, or 2.7, whatever, to the x. And this guy is 10 to the x. So which one's bigger? Which one's going to go up faster? This guy's going to go up faster. This was faster up. Let me kind of scribbling around here. This one's 10 to the x. So it goes up faster. So which one's going up the fastest among these graphs? This red one. This is 10 to the x. And this one must be e to the x because he doesn't go up quite as fast. Right? So the red one is 10 to the x. The blue one is e to the x because e is only 2.7 about. Now the other 2 are the log graphs. So how is that going to work? Let me do a nice tricky way to help you with this. Remember, logs and exponentials are inverse functions. So inverse functions, they reflect across that diagonal line. Let me write a note on that. Inverse graphs reflect across the diagonal line y equals x. So therefore, this 10 to the x graph, he's going to reflect to this guy. This guy's the same thing as him, right? Those guys are inverses of each other. So which one has he got to be? He's got to be log of x. Why? Because there's an invisible 10 there. Remember when you write the log word, the base is an invisible 10? Whoop. Not writing very neatly there. Invisible 10 base. When you have the log word, there's an invisible 10 base. And these guys are inverses. See how they match up right across the diagonal line, the dotted diagonal line from each other? So this has got to be ln of x because there's an invisible e for the ln word. And that goes with the e guy. And then the 10 to the x goes with the log base 10 graph. So there we go. So the green one here, this green one is ln of x. So the green is ln of x. And then the black one must be log x because of the inverse thing. That's a nice way to handle it. Inverse graphs, not just logs and exponentials, but anytime you have an inverse function, the graph is a reflection across the diagonal line. Number 12, match the graphs here. Okay, so how's this gonna work? Okay, so here's a trick. So we're at 1, 2, 3, 4, 5. All right, and notice their order. The blue one's on the top. Now you can't hardly see it from this diagram, but the black one is just barely above the green one. You can kind of see the black rim on the top of that green stripe there, followed by the red one is on the bottom. Okay, so what I'm suggesting, rather than do some formal thing, let's fill in the bases. ln has a base of e, remember? And log has a base of 10. Well, actually, who cares? We don't even need to mess with that. Let's just plug in x is 5 to all these guys at x equals, this is the x-axis, right? X equals 5. Let's see who's highest and lowest. So if you hit ln of 5 in your calculator, you'll get 1.6, basically. And then how are you going to do log base 15 of 5? How do you do this next one here? You do, well, here, let me move it over. Remember how to do that? You do log of 5 over log of 15. Remember the base goes to the bottom, and you hit those two on your calculator. And I'm getting 0.59. The next one, just hit log 5, and you'll get 0.69. I'll just say it's about 0.7. And then this last one is going to be log of 5 over log of 11. Again, the base goes on the bottom. So log of 5 divided by log of 11, and I'm getting 0.67. All right, so which one's the highest number? 1.6. The ln is the highest one. Which one's the highest? The blue. So the ln has to be the blue, A. What's the next highest number? We got a 0.7, that's higher than the other two. So the next highest is the black. So the black, the B for black, has to be that guy. What's the third highest? 0.67. That's going to be the green, which is the C. And the lowest 1.59, that's the red on the very bottom. That's going to be the D. And there we go. That's how you handle that one. Okay, number 13. Now we want to graph this thing. And we're going to actually work backwards on this one. They're telling us to write an equation. All right, using the fact that it passes through 0, 0, and 4, -3. So we're saying it's y equals log, or maybe some number in the front. Here, let's say a times log base b. And what has to be in the parentheses? Remember, look at the vertical asymptote line. Remember how the vertical asymptote lines work? The vertical asymptote lines have to be such that the inside, it's the x that makes the inside of the log 0, right? It's whatever x makes the inside of the log 0. So this is going to be x plus 1, because that way -1, x equals -1 makes the inside 0, and that's where the vertical asymptote line is. So we know it's got that. We know it's got an x plus 1 right there. So now we know it goes through the point 0, 0. So let's plug that in. 0 for x, 0 for y. Plug in 0, 0. So 0 for x and 0 for y. Whoops. Log base b of 0 plus 1. And it's log base b of 1. And that's going to be, remember how we do a log with a funny base? You let the base go to the bottom and the other part to the top. And when you do that, this will just come out 0. So this will be 0 equals 0. That didn't do anything for us. So now let's try the other one. That was plugging in 0, 0. Now let's plug in for -3, which is this point right there. 4, -3 is on the graph. So plug it in to this equation. So this is the x, this is the y. So the y of -3 equals a log base b of 4 plus 1. Right, plug it in for x. So I'm plugging in for x, 4, and for y, -3. What do we get? -3 is a log base b of 5, -3, whoops, is a, now how do we handle this log? The base goes to the bottom. The base goes to the bottom. The other part stays on the top, like that. Oh, whoops, I shouldn't, I'm messing up here. Sorry about this. We're just assuming a regular log on this one. No base b, just a regular log. This part still doesn't give us anything. 0 equals 0. But over here, so just a regular log. So sorry for that confusion. Let's come over here. So no base b, just a regular log. So this is log of 5. So how do we solve for a there? To solve for a, we divide both sides by log 5. So a is -3 over log 5. Sorry, I'm getting a little scribbly there. Like that. So that's a. That's the number that goes in the front. So then our answer is y equals a log of x plus 1, and the a is this. So -3 over log 5. That's weird, but that's all just a big number. Log of x plus 1. There it is. There's our answer. That was a strange one. Number 14. So now they want us to find the equation of the vertical asymptote. Remember where the vertical asymptote is? It's what makes the x to make the inside equal 0. So take x plus 4 and say what x will do that? Well, x negative 4. There's the answer. Now this next one's going to be a little trickier. We take the inside, and now the domain, they want the domain. The domain, remember the inside of a log cannot be 0 and it cannot be negative. You can try it on your calculator. If you try the log of 0 or the log of a negative number like negative 1, either way you'll get an error. You can't have negatives or 0 in a log. The inside of a log cannot be 0 and it cannot be negative. So the inside of a log, oops, let me change the color here. The inside of a log is only positive. So the inside is got to be greater than 0. That means only positive, doesn't it? Greater than 0. So take the inside and say, okay, inside 3 plus 4x, you have to be greater than 0. So now let's solve for x. And so subtract 3 from both sides. 4x is greater than negative 3. Last step to finish getting x alone, divide by 4. X has got to be greater than negative 3/4. Here's how you say that on an interval, right? Because if you have a number line and you have negative 3/4 right here, it's got to be greater. It's got to be to the right. So negative 3/4 to infinity. It's got to be parenthesis because it's not equal to. It's greater than, because it can't be equal to that number. It can't be right on it. And the last one, find the domain and range of this function. So the domain again, the domain is the fact that the inside must be greater than 0. You can't have the inside of a log negative or 0. It's got to be greater than 0. So you take the inside and you say greater than 0, subtract 8. X is greater than negative 8. How do you say that on a number line? It goes from negative 8 to infinity. And the range is always negative infinity to positive infinity because these log graphs always go up and down forever. So there we go.